something immensely large and unknown is hidden beyond the boundaries of the observable universe, and a vast force is drawing huge clusters of galaxies towards it. This is what recent observations of the universe are showing, but what exactly is it? There are many hypotheses, and the topic is highly controversial. But before we embark on this mysterious journey to the edges of the universe and beyond, if you haven't done so already, subscribe to the channel and click on the bell so you don't miss our new videos. To fully understand what's happening at the boundaries of the universe, it's very important to have a good grasp of Newton's theory of gravity. Isaac Newton is considered one of the greatest scientists of all time. He proposed the gravitational theory, which states that in space, every point mass attracts every other point mass with a force that is proportional to the product of their masses and inversely proportional to the square of their distance. In simple terms, we can say that there is an attractive force that acts between every pair of mass-bearing bodies, and this interaction is as strong as the masses are large and decreases with the square of their distance. Well, this is the force that governs the equilibrium of all masses in the universe. The moon orbiting around the Earth, the motion of the planets and stars, everything we see is a consequence of this interaction. But what have scientists discovered by observing the universe? Put very simply, researchers have observed the high-speed movement of some galaxies in a very specific direction, located between the constellations of Centaurus and Vela. This movement is occurring at a tremendous speed, estimated at about 560 miles per second. And it appears that a force, dubbed by researchers as dark flow, is dragging galaxies towards a specific point. However, this point lies beyond the observable universe. When we talk about the observable universe, we refer to that portion of the universe that we can observe from our vantage point. As we know, when we observe the universe, we see images of stars that reach us through photons moving at the speed of light. However, we must not forget that the universe is expanding, and all celestial bodies are moving away from us. Thus, adding these two effects, we know that from our observation point here on Earth, we can only see what is contained within a radius of 93 billion light-years. Despite the universe being only 14.7 billion years old, it is precisely due to its expansion, which began with the Big Bang, that we can see further because celestial bodies whose light left 14.7 billion years ago are now at a greater distance. With this specified, scientists are observing clusters of galaxies moving towards a specific point beyond the observable universe. The fact that this movement occurs due to something unknown has led to the naming of this force as dark flow. Let's return for a moment to Newton's law of gravitation. If galaxies are attracted to a specific point, this happens because there is a mass exerting a force capable of attracting them. And considering the mass of the galaxies, it must be a very massive object. Before continuing and trying to understand what this is about, we need to understand how scientists became aware of this particular phenomenon. As mentioned earlier, the universe is expanding and galaxies are moving away. However, according to current cosmological theories, the universe would be homogeneous and isotropic, meaning it would be the same in all directions we look. There wouldn't be a precise movement towards a single direction, but isotropy would produce random movements in all directions. Actually, as early as 1973, an anomaly in the uniform expansion of the universe was identified. A series of galaxies all showed movement towards a single direction, but at that time, the point of attraction could be identified within our observable universe, specifically near the so-called Great Attractor, an area of space dominated by a high concentration of old and massive galaxies. This anomaly was named the Great Attractor and is located about 250 million light-years from us, with a mass of about 5 million billion times that of our Sun. The Great Attractor, unlike the dark flow, is a simple anomaly in the expansion of the universe. It would simply be the concentration of more matter at a specific point in the universe, attracting more matter due to gravitational law. But what differentiates the anomaly of the Great Attractor from the dark flow? While the gravitational influence of the Great Attractor is hypothesized to derive from its mass, the case of the dark flow appears more complex. Firstly, it lies beyond the observable universe, so we cannot see what it is. More incredibly, it would be a massive entity capable of attracting even the Great Attractor. So what could be causing this mysterious dark flow? Initially, it was hypothesized that it might be a cluster of dark matter or dark energy. But this theory has been rejected because there is no observation of dark matter in the direction of the dark flow. And as for dark energy, the model of the universe suggests that it has a homogeneous distribution in space. An additional hypothesis has been presented by some researchers, suggesting that the phenomenon might be an extremely massive cluster, similar to the Great Attractor. However, in this case, it wouldn't be an anomalous presence of galaxies, but rather something much larger and somewhat difficult to imagine. Another universe. This other universe would border ours and cause this incredible attraction. Laura Mersini, a physicist at the University of North Carolina, tries to explain this theory simply. If our universe is all that exists, then everything within it must remain stationary. But if what exists is being attracted in one direction, it means there must be something much larger than the dimensions of our universe. There's a structure beyond the visible horizon of our universe, and that structure is exerting a force on our universe, creating the dark flow. Supporting this fascinating theory is string theory, which predicts the possibility of other universes. Thus, if we accept the idea that the dark flow might be concealing another unknown universe, we must consider that ours is not merely expanding as stated by the model theorized by Edwin Hubble, but is also being drawn in a singular direction. Of course, if confirmed, this would be a huge revolution in the field of cosmology. But as we stated at the beginning, dark flow is a very controversial and highly debated matter. Even today, there's ongoing debate about the authenticity of the phenomenon, and there is no consensus in the scientific community. This mysterious force easily falls into the category of dark phenomena, those cosmic mysteries that science has yet to fully understand and which require ongoing investigation. If the existence of dark flow were definitively confirmed, it would undoubtedly challenge everything we know, with the added complexity that whatever it is, it lies beyond everything we can currently observe, and perhaps beyond what we may ever be able to observe. Discussing dark flow has taken us to the edges of the universe and of our knowledge. What do you think? Is dark flow proof of the existence of parallel universes? Let us know your thoughts in the comments, and if you liked the video, subscribe to the channel to continue with us on this incredible journey into the mysteries and wonders of the universe.